Right, guys, so we have some questions regarding kinetics MCQ. So hopefully go through this one will help you guys. Question 9, right? It says that using a calorimeter, the following reaction is studied by finding the time taken for a colored reactant F to decolorize. So guys, just to be clear, right? You are following the rate, you're monitoring the progress of the reaction by looking at the color intensity of F, which is one of your reactant. Okay, so F itself may also influence the rate of reaction. So we got to bear that in mind. The reaction is catalyzed by H and the following results are obtained. So you got F, G, and H, all possible to have an effect on the order of reaction. Okay, so if we look at all the volume, right, first thing we want to check through is that we are comparing all the same total volume, which is about 50. Are we? Experiment 1 is 50, experiment 2 is 50, experiment 3 is 50, experiment 4, is it 50? Yeah. So we're all comparing the same total volume, so we don't have to change any of the experiment. If let's say you found out that one of the experiment, right, the total volume is 25. Okay, what you can do is you can actually multiply all the volumes by 2 so that you can get all of them to the same total volume so that you can do your comparison. Okay, if let's say you find that one of the experiment is different, in this case no, it's all at the same total volume, so it's good. So first, check your total volume. Total volume is all good. Let me make this a little bit thicker, yeah, so that you can see. Okay, so number one, check total volume. Okay, check your total volume, which is good. So we checked it already. And then next, we're going to try to compare experiment 1 or 2. Okay, and then we'll see which one can keep two of the reactant constant and then only vary one. So we keep F and H constant. We double. Let me thicken this a bit more. Okay, we double the concentration for G because volume is directly proportional to concentration here. Okay, so when we double, the time taken is halved, which means that the rate is double as well. Okay, so order of reaction with respect to G, order for G is 1. Okay, so we got that. Then how about, let's erase this. Okay, maybe we just write it down, right? The rate is inversely proportional to time. Okay, so just take note of that. We want to now compare, other than G, let's compare. Okay, so there's a difference in experiment 2 and 3. So we keep F constant. We halve the concentration of G and we double the concentration of H. Okay, what happens to the time taken? It remains the same. So what does it mean? It means that when you halve the concentration of G, you expect the time taken to double, right? But the time taken stays the same, which implies that the order of reaction for H is also 1. Okay, right? So because H double in the concentration, right, which negates off the halving of the concentration of G, since they are both first order, so they negate off, the time taken stays the same. All right, so that is it for comparing 2 and 3. Last one we want to compare for F, right? F, remember, we are following the color intensity, so just keep that in your mind. let's choose, okay, we can choose experiment 3 and 4. Keeping G constant, right? Keeping G constant, we halve the concentration of H, half the concentration of H. Oh, actually, there's an easier version. Let's not choose this. Let's choose 1 and 4. Experiment 1 and 4. Okay, so G is kept the same. H is also kept the same. Yeah, so it's just F is double. What happened to the rate of reaction? The time taken is the same. So the rate, most of us would have thought that A is kept the same. It's kept the same. It didn't change. So we thought that is zero order, but it's not zero order, guys. Remember, if you double the concentration of F, right, and you are following the color intensity of F, okay, so number one, if you're following the color intensity of F, and F is zero order, if F is zero order, if F zero order, right, you double the concentration of F, the rate is, it doesn't affect the rate of reaction. If you double the concentration, then what will happen? The time taken, right? The time taken will double as well, because you got double the number of particles, right? So the rate will actually half. The rate will actually half. Okay, I'm sorry, I didn't know you cannot see that. Okay, the rate will actually half. Oh, let me write that again. If you double the concentration of F, the rate will be halved. Okay, so the rate will be half if you double the concentration, if it was zero order. Okay, but it is not zero order, because when we look at our data, the time taken stayed the same, which means that F should be first order, because F, right, when you double the concentration, the rate also double. But because there's twice as many of F particles, right? So the two effect will negate off each other. Okay, so order of reaction for F is 1. Okay, so order of reaction for F is also 1. Okay, so this is a very, very crucial assumption that I think you will want to take note of. Okay, if F is zero order and you double concentration of F, the rate will actually be half, because it will take twice as long. You have twice as many F particles. This is very easy to understand. But if you take it one step further, right? Then why is it here? Why is it here when the time taken, right, is the same? What does it mean? The time taken is not double. It stays the same, because the rate of reaction, right, the speed of the reaction is actually double. Okay, so when the speed is double, let me just write that down. When the rate is double, and then the time taken, right, time taken is double, these two will actually negate off each other. That's why you see the final rate of reaction, or the time taken, is the same. Okay, because while the particles are reacting twice as fast, but there are twice as many particles to react. Okay, so these two effects will cancel out each other. Okay, I don't know whether you guys understood what I said. If not, please leave a comment. Let me know how to make you understand. Okay, so leave me your questions in the comment, and then I'll see how I can further clarify it if you still don't understand. Okay, see you in the next video. Bye.